What's up guys, and welcome to this video tutorial on the 2018 IEB exam, the AP Maths exam. We're going to go over question 11, which really has to do with your understanding of integration. So you don't need to actually integrate anything, but rather have an understanding of the rules of integration and how integration actually works. Okay, so question 11. In the diagram below, the function f of x has been drawn. The function g of x, which is equal to f of x plus kx plus 1, with k being a rational number, has also been drawn. Okay, so we have g of x. Let's do this. So g of x is going to be in green. Probably going to need something a bit thicker. So we have g of x and we have f of x, which is in red. Okay, right there. If the area bounded by the functions, by the two functions, and the lines x equals 1 and x equals 7 is 54 units squared, then determine the value of k. Okay, so what we have to remember is that this area, the area they're talking about is the area between both of these curves. Okay, but this can be broken down, right? Because what we actually have is this green area. It might be easier if I draw it on a separate graph. So let's put my drawings to the test. Okay, so if we sketch out this graph, and we have g of x, so we have g of x, okay, and on another graph right next to it, we have f of x. Okay, it looks something like that, and we have 1 and 7, and we have 1 and 7, right? In order to get this area that they've shown us, this area right here, all we have to do is take the area of g of x, which is that full area, okay, that's the bigger area, and minus it from the area of f of x, because that's just the area under f of x. And what we get if we add these two together, let's see if we can actually get this to work. If we put one graph over the other, okay, the remainder is that area that we're looking for. So what we're left with is that area that we're looking for, which is this area right here, or in this case, this gray area right here. Okay, so that's the understanding behind it. So you guys don't really need to care about any of that if you understood it, but I just wanted to try explain what's actually happening. Okay, so with that out of the way, we can just minus the two areas from each other. So our area, our total area, is equal to the integral of 1 to 7 of g of x minus f of x dx. Okay, so this is equal to the integral from 1 to 7, and g of f was equal to f of x plus kx plus 1 minus f of x dx. Okay, and this is equal to the integral from 1 to 7. These f of x's cancel, so it's kx plus 1 dx. Okay, so now we can actually integrate this. So we can say that that's equal to the integral, we're integrating in terms of x, so that's going to be k, which is our constant, x squared over 2 plus x. Okay, and the bounds are between 1 and 7. Okay, so what we need to do now is we can impose our limits on here, our boundary conditions. So that's 7 squared, which is 49k over 2 plus 7 minus, now we put 1 into where x is, so that's k over 2 plus 1. Okay, which is obviously equal to 49k over 2 minus k over 2 plus 7 minus 1. Okay, which we can say is actually equal to our area, which is 54 units. From the question, 54 units. Okay, so now we can multiply this up, or we can actually 49 over 2 minus 1 over 2 is equal to 24 plus, so 24k, sorry, 24k is equal to 54 minus 7 plus 1, 48. Okay, so that means k is equal to 2. So not too bad, okay? So we know that k is equal to 2, which was what we wanted to find. Yeah, determine the value of k. And that's all we really need to do. And k is equal to, k needs to be rational, and k is equal to 2, which is a rational number. So that is the answer. Yeah, so a nice easy question, nothing too difficult. The main understanding was that we can take the integral g of x minus the integral of f of x and make that equal to our total area. And once you had that, there was really nothing too difficult. Okay, so thanks for watching, guys. I hope you found this useful, and in the next video we will go over question 12.